We are doing on Hadoop Mapreduce. How does Hadoop Mapreduce work? Hadoop consists of the processing Hadoop Mapreduce and a storage Hadoop HDFS, which is the distributed file system. The Hadoop Mapreduce is a processing unit which then processes the data in the Hadoop HDFS. The data stored in Hadoop HDFS is not stored in a traditional way. The big data is divided into different types of data and stored in its respective data nodes, which means there are no complete data exist in the respective data nodes. Hadoop Mapreduce split the input data set into independent chunks which are processed by the map task in a completely parallel manner. The framework sort the output of the map, which are then input to the reduce task. Both the input and output of the job are stored in a file system. The framework takes care of scheduling tasks, monitoring them, and re-execute the failed task. So in the input, there's apple, banana, and carrot, for example. So for the splitting phase, it will split the data into key 1 and value 1. In mapping phase, it will categorize the value of key 1 v1 into a list of key 2 and value 2. With that, it will start to shuffle to key 2 and a list of value 2, which will be bind to the key 2. In the reducing, it will add on the number of values into example apple, 3. And for the final result, it will add everything in the reduced task to the final list of key 3 and value 3.
In class, the MapReduce that we learned is popularized by Google. Google also has this Google File System to manage their large amount of data. Google File System, or GFS, is a proprietary distributed file system developed by Google to provide efficient, reliable access to data using large clusters of commodity hardware. They were implemented to meet the rapidly growing demands of Google's processing needs. The Hadoop Distributed File System, or HDFS, is highly fault-tolerant and is designed to be deployed on low-cost hardware. Because HDFS typically is deployed on low-cost commodity hardware, server failures are common. The file system is designed to be highly fault-tolerant by facilitating the rapid transfer of data between compute nodes and enabling Hadoop systems to continue running even if a node fails. When HDFS takes in data, it breaks the information down into separate pieces and distributes them into different nodes in a cluster. The file system also copies each piece of data multiple times and distributes the copies to individual nodes. As a result, the data on nodes that crash can be found elsewhere within a cluster. This allows processing to continue even when there is a failure. HDFS is built to support applications with large datasets, including individual files that can reach up to a few terabytes. It uses a master-slave architecture, with each cluster consisting of a single name node that manages file system operations and supporting data nodes.